In the endless darkness of the cosmos, where light takes millions of years to reach human eyes, silent dangers wait in ambush. Not all of them appear as blazing collisions or the thunder of supernovae that we often imagine. Some threats come from wandering stones that drift across the solar system, from orphaned planets adrift without stars, from invisible radiation that pierces both flesh and memory. Others rise from the instability woven into the very fabric of the universe itself, where dark matter and dark energy act like unseen hands, bending the destiny of galaxies. And sometimes the most perilous thing of all is the silence, so deep, so unbroken, that it makes us wonder, is the universe concealing a script that human intelligence has never been ready to face? Together, we will explore 32 real dangers that exist in space, not as prophecy, but as mirrors reflecting the fragility of life on a small planet called Earth. This is more than a scientific journey. It is a passage into the heart of existence itself, through the lenses of time, physics, and mysteries yet to be revealed. Welcome to Arcane Skies. If these stories stir your curiosity, leave your mark by liking, subscribing, and sharing where and when you're watching the skies with us. The first danger does not announce itself with spectacle, nor does it roar with the fury of a collapsing star. It drifts, almost invisible, across the cold expanses of the solar system. Interstellar wanderers, fragments of ancient collisions, shards of forgotten worlds. These are comets and asteroids, bodies of stone and ice older than the Earth itself, carrying the memories of a violent cosmic past. In scientific terms, they are called near-Earth objects. Yet their nearness is not comforting. Each one is a reminder that the sky above is not empty, but alive with trajectories that sometimes cross our own. Imagine a mountain of rock tumbling silently through space, its surface scarred by eons of radiation, its orbit shaped by gravitational nudges from giant planets like Jupiter. It carries no intent, no malice, yet if chance aligns its path with Earth's thin atmosphere, the consequences would be catastrophic. History has recorded whispers of such impacts. The Tunguska event in 1908, when a small asteroid or comet exploded over Siberia, flattening thousands of square kilometers of forest. The Chicxulub impact 66 million years ago, when a far larger body struck the Yucatan Peninsula, ending the age of the dinosaurs and rewriting the story of life. These were not myths, not legends, but geological scars etched into stone and memory. Science tells us that Earth moves through a cosmic shooting gallery. The asteroid belt between Mars and Jupiter is not the only reservoir of potential threats. Beyond Pluto lies the Oort cloud, a vast sphere of icy remnants stretching halfway to the nearest stars. Occasionally, a passing star or subtle gravitational shift sends one of these frozen bodies inward, accelerating toward the inner solar system. When such an object appears, it is not bound to the familiar rhythm of planets. It is a messenger from the depths, unpredictable, often detected only when it's already close. Modern telescopes scan the heavens, mapping these wanderers with algorithms that predict their courses. NASA's Planetary Defense Coordination Office, a name that seems lifted from the pages of science fiction, quietly catalogues thousands of near-Earth asteroids. The European Space Agency builds plans for missions to deflect or disrupt them, testing humanity's ability to change the fate of a rock moving faster than a bullet. Yet for all this vigilance, countless smaller objects remain unseen. A fragment only a few hundred meters across could level a continent. One just 50 meters wide, no larger than a city block, could erase a metropolis in an instant. What makes these bodies so dangerous is not only their size or speed, but their silence. Unlike storms, they do not gather clouds. Unlike volcanoes, they do not rumble warnings beneath our feet. They travel in darkness, revealed only by faint glimmers of reflected sunlight. To the unaided human eye, they are indistinguishable from stars until motion betrays them. In this sense, they embody the essence of cosmic danger. Vast, indifferent, and hidden until the final moment. There is a paradox here. The same objects that threaten life have also given rise to it. Comets, carrying water and organic molecules, may have seeded Earth's oceans in its earliest days. Some scientists suggest that the building blocks of DNA itself arrived riding on icy travellers from interstellar space. The threat and the gift are inseparable. Destruction and creation braided into one narrative, as if the universe itself operates on the principle of duality. But what of the truly alien intruders, those that do not belong to our solar system at all? In 2017, astronomers glimpsed something extraordinary, an object later named Oumuamua, Hawaiian for scout. It was elongated, tumbling, accelerating in ways that challenged traditional understanding. Unlike any comet or asteroid seen before, it came from beyond the solar system, a fragment cast adrift from another star. By the time its presence was realized, it was already on its way out, leaving more questions than answers. Was it natural? Was it artificial? Could interstellar objects like this be carriers of both unknown danger and unknown knowledge? The silence it left behind lingers like a riddle without resolution. In contemplating these wanderers, humanity is confronted not just with physical peril, but with a deeper awareness of fragility. Civilizations rise and fall on Earth, believing themselves secure, while above, countless silent projectiles cross invisible paths. The mathematics of probability tells us that catastrophic impacts are rare, but given enough time, they are inevitable. A single strike could end an era, extinguish cultures, or force life to begin again from the ashes. And yet, perhaps it is this very vulnerability that sharpens human curiosity, that pushes science to scan deeper, to build defense where once there was only fear. The DART mission in 2022, a spacecraft deliberately crashing into the small asteroid Dimorphos, marked the first attempt to shift the course of a celestial body. It was a proof of concept, a whisper of defiance against the indifference of space. For the first time, humanity touched the trajectory of fate and altered it. Small, imperfect, but undeniable. Still, the universe is vast, and the unknown always outnumbers the known. Even as telescopes watch, even as algorithms predict, there remain dark spaces between stars where the next threat may already be on its way, invisible against the blackness. Perhaps it will arrive tomorrow, perhaps in 10,000 years. The uncertainty itself is a shadow that stretches across imagination. As this journey begins, with the silent stones of the cosmos as our first encounter, one must wonder. What other dangers, hidden deeper in the fabric of space, wait for their moment to step from obscurity into destiny? If rocks can fall from the heavens without warning, what are forces more subtle, less tangible, yet far more destructive? The answer lies not in the asteroids themselves, but in the invisible ocean they swim in, a universe filled not only with matter we can see, but with forces we cannot yet touch, forces that shape the orbits of galaxies, that dictate the very expansion of space itself, forces that may not collide like stone, but dissolve reality from within. And so the gaze must shift outward, from wandering rocks to the unseen architecture that holds the cosmos in its grip, carrying us into the next revelation of peril. If wandering rocks remind us of the fragility of Earth, the second danger reaches far deeper into the invisible structure of the universe itself. For all the brilliance of stars and the radiance of galaxies, the cosmos is built upon a foundation we cannot see. Scientists call it dark matter, a phrase that is both poetic and unsettling. It neither emits nor reflects light, yet it outweighs everything visible by a factor of 5. Without it, galaxies would fly apart, their stars drifting like scattered embers in a storm. Dark matter holds them together, a silent scaffolding woven into the cosmic web. And yet, because we cannot touch it or measure it directly, it remains a mystery as vast as the void. The danger lies not in the existence of dark matter itself, but in what it implies. If most of the universe is made of something beyond our senses, then humanity lives inside a reality that is only partially revealed. Imagine standing inside a cathedral at night, holding a candle that illuminates only a fraction of the towering walls. The structure is there, immense and complex but unseen. Every calculation of destiny, every theory of beginnings and endings rests on what we cannot fully grasp. If dark matter were to shift in its properties, even by a fraction, stars would no longer bind into galaxies, planetary systems would unravel, and the familiar stage upon which life unfolds would dissolve. To glimpse the influence of this hidden mass, astronomers map the bending of light across the heavens. Light should travel straight, yet in regions dense with dark matter, it warps and curves, creating arcs and smears, an effect known as gravitational lensing. In these distortions, the invisible reveals its fingerprints. Entire clusters of galaxies bow and twist under the grip of something unseen, like puppets pulled by strings of shadow. Some theorists whisper of darker possibilities. If dark matter is not merely inert scaffolding, but part of a dynamic field, then fluctuations in its distribution could have catastrophic consequences. What if streams of dark matter, flowing unseen through the galaxy, occasionally intersect with planetary systems? Earth itself may be moving through invisible rivers of dark mass, the effect subtle now, but potentially disruptive in ways we do not yet understand. But if dark matter is enigmatic, then its companion, dark energy, is even more ominous. While dark matter holds galaxies together, dark energy tears the cosmos apart. It is the force driving the acceleration of the universe's expansion, discovered in 1998 when distant supernovae appeared dimmer than expected. Instead of slowing down after the Big Bang, the universe is speeding up, as though some hidden hand is stretching space itself. And here lies one of the deepest dangers of all. If dark energy continues to accelerate the cosmos, the future may be a place where galaxies vanish beyond a cosmic horizon, where stars grow lonely in an ever-dimming sky. There are scenarios painted by cosmologists that chill the imagination. In one, the acceleration never stops. Galaxies drift apart until even the nearest clusters disappear from view, leaving future observers in a cosmic solitude, blind to the history written in starlight. In another, the acceleration increases until, billions of years from now, it tears even atoms apart in a catastrophe known as the Big Rip. Molecules, protons, and the very fabric of space-time could be shredded by an expanding void that recognizes no boundary. It is easy to dismiss such outcomes as too distant to concern us. But the danger is not confined to the remote future. It lies in the recognition that the universe is governed by a force we cannot predict, a force we cannot control, one that dictates the fate of all existence. Humanity builds civilizations with stone and steel, yet the foundation rests on currents of energy that lie utterly beyond comprehension. And then comes the most unsettling thought of all. What if dark energy is not constant? If it fluctuates, if it changes over time, then the stability of the cosmos is far less certain than we imagine. The balance that allows stars to shine, that allows planets to orbit, may be temporary. The universe could lurch into new phases of expansion, each rewriting the laws of possibility. There are moments when scientists speak of these forces in the language of metaphor, not because they wish to mystify, but because language itself struggles to contain such enormity. Dark energy becomes a storm, an ocean, a tide. Dark matter becomes a hidden skeleton, a scaffolding of shadow. And yet the truth may be stranger than any image, stranger than the sum of all metaphors. Consider this. If the cosmos is shaped by invisible forces, what does that mean for life itself? Is consciousness an accident of matter in the small corner we can see? Or is it somehow entwined with the larger fabric, the unseen architecture that holds it all together? Some philosophers suggest that the very fact we can ask these questions hints at a deeper resonance between mind and cosmos. If most of reality is dark and hidden, then perhaps awareness itself is a spark cast against a backdrop of shadow, fragile yet defiant. The danger of dark matter and dark energy is not a collision, not an explosion, not a visible catastrophe. It is the abyss of uncertainty, the recognition that existence itself depends on something we cannot yet name. It is the possibility that the universe may not be what it seems, that its future is written not in the stars we see but in the silence between them. And so, from the stones that wander through the solar system, the gaze now turns outward to the unseen forces that hold and unmake the cosmos. Yet even these are not the end of peril, only the beginning. For beyond the scaffolding of dark matter, beyond the tide of dark energy, there are deeper abysses still, ruptures in space-time itself, places where the laws of physics collapse and where even light cannot escape. What waits in those regions is not just hidden, but forbidden. Realms that pull not only on matter, but on imagination itself. If dark matter and dark energy are the unseen tides that shape the universe, then black holes are its most intimate abysses, places where those tides collapse into singular silence. To speak of them is to speak of finality. They are not simply objects. They are regions where the very concept of place unravels. A black hole begins when a star of sufficient mass reaches the end of its life, its nuclear fires exhausted. Gravity, no longer opposed by pressure from fusion, becomes absolute. The star implodes, compressing matter into a point so dense that the known laws of physics shatter. That point is called a singularity, though the word is only a placeholder for what no equation can yet describe. Surrounding the singularity lies the event horizon, the boundary from which not even light can escape. It is not a surface in any conventional sense, but a threshold where all trajectories bend inward. To an outside observer, anything that falls into a black hole appears frozen at the horizon, stretched and dimmed by gravity's grip, a phenomenon known as spaghettification. Yet from the perspective of the falling object, the descent continues, inescapable, into regions where time itself distorts beyond recognition. The danger black holes present to Earth is not that one sits nearby, waiting to consume us. Astronomers assure us there are no giant black holes lurking within the immediate range. The closest known stellar black holes are thousands of light years away, while the supermassive one at the centre of our galaxy, Sagittarius Aeon, is a distant giant, shaping stellar orbits but posing no direct threat. And yet, the peril lies in their unpredictability. If a rogue black hole, wandering invisibly through interstellar space, were to drift close to our solar system, its gravity could disrupt planetary orbits, sling asteroids into Earth, or even pull our planet itself from its sunlit cradle. Astronomers speculate about primordial black holes, tiny relics born in the chaos after the Big Bang. Unlike their stellar cousins, they may be the size of mountains or smaller, but with the mass of Earth compressed into a sphere invisible to detection. If such a relic crossed paths with our world, the encounter would not be heralded by a blaze of light, but by quiet devastation, subtle gravitational distortions, tides gone wild, until Earth itself was torn apart. Beyond their physical threat lies a more profound danger. Black holes are wounds in our understanding. At their cores, the equations of general relativity, Einstein's elegant description of space-time, break down. Infinity emerges where nature rarely permits it. For decades, physicists have struggled to reconcile black holes with quantum mechanics, the theory that governs the subatomic. The conflict gave rise to what Stephen Hawking called the information paradox. If matter falls into a black hole and is lost forever, what happens to the information it carried, the arrangement of particles, the patterns of quantum states? Physics tells us information cannot be destroyed, yet black holes seem to erase it. The universe recoils at such contradictions, but offers no answer. Some believe that black holes do not erase but transform. Hawking radiation, a faint emission predicted by quantum theory, suggests that black holes slowly evaporate, releasing energy over unimaginable spans of time. If true, then no black hole lasts forever. Even the giants at galactic centres will one day dissolve into nothing. But the process is so slow that the universe itself may end long before the last black hole flickers out. Other thinkers whisper of stranger possibilities. Perhaps black holes are not ends at all, but beginnings. Some theories propose that what falls into a black hole emerges elsewhere, in another universe, another dimension, through a channel called a white hole. If so, then each collapse may be the birth of a new cosmos hidden from ours, inaccessible yet linked. In this vision, the multiverse is seeded not by a single Big Bang, but by countless implosions scattered across eternity. For humanity, the peril of black holes is double-edged. On one hand, they represent cosmic predators, unseen, capable of erasing entire worlds without warning. On the other, they represent the collapse of certainty itself, the point where human reason fails, where mathematics falters, where the map of knowledge is ripped apart. They are danger not only to life but to understanding. And yet, paradoxically, black holes illuminate as much as they obscure. In studying them, scientists probe the limits of physics, forcing new ideas to emerge. The Event Horizon Telescope, a network of observatories spread across the Earth, captured the first image of a black hole's shadow in 2019. A ring of fire encircling darkness, light bent to the breaking point. It was not just a picture, but a revelation, proof that even the most forbidding objects could be glimpsed, however faintly, from the shores of our fragile planet. To stand beneath the night sky and think of black holes is to feel the weight of inevitability. Somewhere, unseen, stars are dying, collapsing into silence. Somewhere, galaxies are being sculpted by central monsters so massive that millions of suns would vanish inside them. And somewhere, perhaps closer than we dare to imagine, a rogue black hole drifts on a path that cares nothing for the worlds it may scatter. If stones remind us of our fragility and dark energy of our uncertainty, then black holes remind us of our limits. There are regions where knowledge ends, where imagination must step in to fill the void, and where danger comes not only from what might strike, but from what might never be understood. From the silent wanderers of stone to the hidden tides of shadow, to these chasms of collapsed stars, the pattern emerges. The universe is filled not with comfort, but with thresholds. Each danger is not only physical, but existential. To cross them is to confront not just peril, but the boundaries of meaning itself. And yet, beyond the black holes there are dangers more elusive still. For even if matter collapses and light is devoured, there remain forces that ripple invisibly across the cosmos, waves that stretch and compress reality itself, carrying echoes of cataclysms long past. They travel silently, but their message is profound. The universe itself can quake. From the collapsed hearts of stars, attention shifts to something more subtle but no less unsettling. The tremors of the cosmos itself. Space is not rigid. It is elastic, capable of stretching and compressing like an unseen fabric. When titanic events occur, the collision of black holes, the merger of neutron stars, they send ripples across this fabric. These ripples are called gravitational waves, and though invisible, they carry the most ancient and violent messages of the universe. Imagine reality itself quivering. A pair of black holes spiral toward one another, their dance tightening as energy radiates outward. The moment they collide, waves rush through space-time at the speed of light, distorting everything they pass through. If such a wave were to wash over Earth, the entire planet would expand and contract ever so slightly, by less than the width of an atom, too small to harm directly, yet profound enough to reveal that nothing in the cosmos is still. For most of history, such waves were only theory. Einstein predicted them in 1916, but for a century they remained ghosts, unmeasurable, hiding beneath the noise of existence. Then, in 2015, the Laser Interferometer Gravitational Wave Observatory, LIGO, captured the faint signature of two black holes colliding more than 1 billion light-years away. It was not an explosion of light, but a whisper of distortion, a ripple in the invisible fabric. Humanity had, for the first time, heard the universe. The danger lies not in the waves themselves, but in what they represent. Each detection is a reminder that cataclysms are commonplace. Galaxies are shaped not by tranquility, but by violence, and collisions that dwarf the energy of all the stars combined occur routinely in the dark. Gravitational waves are the echoes of such destruction, arriving long after the events have finished, like thunder from a storm already past. Yet their existence reminds us that the universe is restless, that structures we consider permanent are constantly being remade. Neutron star collisions, another source of gravitational waves, add a further layer of peril. Neutron stars are remnants of massive suns, their matter compressed into spheres only tens of kilometers wide but heavier than the Sun. When two of them spiral together, the impact produces not only gravitational waves but showers of heavy elements: gold, platinum, uranium. The jewellery humans wear, the circuits that power machines, all may trace their origins to such cosmic violence. But the same collisions also unleash bursts of gamma radiation, beams so intense they could sterilize entire planets if aimed in their direction. To be in the path of one is to face annihilation faster than thought. So far, Earth has not been struck by such a burst in human history, but the fossil record hints at strange extinctions that may align with gamma flashes. A brief wave of radiation could strip away the ozone layer, bathing Earth in ultraviolet death from the Sun. The peril is compounded by invisibility. These beams travel across millions of light years, giving no warning, no chance for preparation. The true terror of gravitational waves and their kin is not the scale of damage they bring, but the realization that the universe can convulse at any moment, indifferent to time or place. Black holes collide whether or not eyes are watching. Neutron stars merge whether or not minds exist to calculate. And the waves ripple outward, brushing through worlds that never know they have been touched. Yet there is another dimension to the danger: the fragility of knowledge itself. Each detection challenges humanity to expand its instruments, to refine its mathematics, to listen more carefully to the murmurs of the void. The discovery of gravitational waves has opened an entirely new way of perceiving the cosmos, not with sight, but with resonance. We are now listeners in a cosmic symphony, but what if some notes are too deep, too violent, too alien to comprehend? What if the universe carries signals we cannot yet recognize, warnings encoded in tremors too faint or too complex for our machines? In the mythology of ancient cultures, earthquakes and storms were often interpreted as the voice of gods. Today, gravitational waves could be seen as the universe's own voice, a deep, resonant speech that bypasses light and matter, speaking directly through the bones of reality. And like the gods of myth, this voice is not always kind. It tells of annihilation so absolute that even light is extinguished. But perhaps the gravest implication is this: if the fabric of space-time can ripple, it can also tear. Theoretical physicists have speculated about cracks in the cosmic weave, topological defects left over from the earliest moments after the Big Bang. These hypothetical structures, called cosmic strings, could stretch across galaxies, thinner than an atom yet carrying energies vast enough to rupture worlds. If they exist, their vibrations would be catastrophic, capable of sending shockwaves that remake the universe at unimaginable speeds. And so the quiet ripples detected by LIGO are not merely discoveries, they're glimpses of a deeper truth. Reality itself is not fixed but dynamic, vibrating, trembling, vulnerable. To live within such a universe is to inhabit not a fortress of permanence, but a sea of motion where any calm may conceal a coming storm. From the perspective of Earth, such storms feel distant. 1 billion light-years is a span too great to carry fear into daily life. But the distance does not erase the message. Every detection is a reminder that the same laws that govern distant cataclysms also govern us. Gravity, radiation, time, all are woven together. To hear the echoes of colliding black holes is to hear our own fragility sung back across eternity. And if the universe can quake, if its very fabric can tremble, what else might lurk within those tremors? Could the ripples themselves carry information, hidden patterns like signals coded in the static of reality? Could what we perceive as blind forces also be the channels through which deeper mysteries reveal themselves? As the waves fade and the instruments fall silent, the imagination cannot help but wander beyond. What dangers are born not of collisions or collapse, but of emptiness itself, the spaces where energy thins, where stars die, where silence grows absolute? What lies at the far edges of light, where the universe becomes not violent but cold, and where the final enemy is not destruction, but nothingness? From the quakes of space-time, thought drifts outward to another peril, one not marked by explosions or collisions, but by silence and cold. For while stars blaze for billions of years, their fires are finite. The universe, despite its radiance, is slowly running down. Every sun that shines will one day exhaust its fuel, and when stars die, they leave behind remnants that populate the cosmos with danger. White dwarfs, neutron stars, and the long, slow fading of light itself. The death of an ordinary star is deceptively beautiful. As it runs out of hydrogen to burn, its core contracts while the outer layers expand, swelling into a red giant that can engulf entire planetary systems. Mercury, Venus, and perhaps even Earth will be consumed when our Sun undergoes this fate 5 billion years from now. For a time, the star's outer layers glow, drifting into space as delicate clouds of gas, a planetary nebula. At the centre remains a white dwarf, a small, dense ember, no larger than Earth but with the mass of the Sun. It no longer burns fuel, it simply radiates away its remaining heat. Over trillions of years, white dwarfs will cool into black dwarfs, cold remnants that shine no more. The danger is not only in the eventual death of our Sun, but in the unpredictable behaviour of stars around us. White dwarfs in binary systems can siphon material from their companions. As the matter piles up, pressure builds, until, suddenly, a thermonuclear explosion erupts, a type of Gihua supernova. Such events shine brighter than entire galaxies for weeks at a time, visible across billions of light years. If one were to occur within a few dozen light years of Earth, the radiation would devastate our biosphere, stripping ozone and scalding the surface with lethal rays. Scientists reassure us that no such nearby candidates are known, yet the vastness of the sky hides countless possibilities. Then there are neutron stars, stranger still. When a massive star collapses, the pressure is so great that protons and electrons fuse into neutrons, creating an object of staggering density. A teaspoon of neutron star matter would weigh billions of tons. Their magnetic fields are trillions of times stronger than Earth's. Their surfaces so warped by gravity that space itself curves visibly around them. Many spin rapidly, beaming radiation into space like cosmic lighthouses. These are pulsars, their signals detected on Earth as rhythmic pulses of radio waves. To encounter a neutron star up close would be to face annihilation. Its radiation could sterilize planets across great distances. Its gravitational pull could rip a world apart long before direct impact. And in rare cases, neutron stars collide, producing bursts of gamma rays capable of reaching across galaxies. Death flashes that leave no second chance. Yet perhaps most haunting of all is the quiet fate of stars that die without spectacle, fading gradually until their embers vanish into the black. Over unimaginable spans of time, the universe will cool as more and more stars burn out. Galaxies will lose their brilliance, clusters will thin, and light itself will retreat. This is the slow march toward heat death, the final entropy, when energy is so evenly distributed that no work, no motion, no life can persist. For now, this end lies beyond comprehension, billions upon billions of years away. But the danger is not only in the end itself, it is in the recognition that the universe is not eternal in its current form. The fires that cradle life are temporary. Civilizations rise under the illusion of permanence, but the stars above are already on their way to silence. Some scientists imagine alternative endings. Instead of fading, the cosmos might one day collapse inward, reversing expansion in a cataclysmic big crunch. Or dark energy might destabilize, leading to the Big Rip, shredding galaxies, atoms, and even space-time. Yet the heat death remains the most widely accepted, an ending not of fire but of frost. It is a universe where every danger has already played out, every star extinguished, every black hole evaporated, until nothing remains but cold uniformity. This vision is difficult to reconcile with human imagination. Cultures across history have told stories of endings, floods, flames, rebirths. But the heat death offers no rebirth, no cycle, only infinite stillness. In that sense, it may be the most profound danger of all. Not destruction, but absence. A cosmos emptied of meaning, where even memory is dissolved into the dark. And yet, in contemplating such endings, a strange perspective emerges. To know that stars will fade is to cherish their light more deeply now. To know that existence is fragile is to value each fleeting moment of radiance. The universe itself becomes a story told in sparks, brief against eternity, yet brilliant while they last. But while cosmic cold remains a distant threat, other stellar deaths loom closer. Supernovae may bloom, pulsars may lash out with deadly beams, and white dwarfs may erupt without warning. The night sky, so serene to human eyes, is in truth a battlefield of dying suns. To watch the stars is to watch an endless cycle of birth and annihilation, each light a reminder that even brilliance carries the seed of its own destruction. As the thought of fading sun settles, attention is drawn not only to the stars themselves, but to the spaces between them, vast regions filled with invisible hazards. Cosmic rays, high-energy particles accelerated by explosions and magnetic storms, streak through the galaxy, colliding with atmospheres, altering DNA, reshaping the fragile chemistry of life. They are silent assassins, striking from distances so great that their sources remain uncertain. Some may be born from dying stars, others from forces still unknown, but their reach is constant, their impact steady. And so, from the violence of collapse to the silence of heat death, the universe reveals another of its dangers, time itself. Time strips light from stars, dissolves energy into entropy, and erases what once seemed eternal. To live in the cosmos is to live on borrowed light, knowing that the candle will burn out, but not knowing when or how. If the death of stars feels final, there are perils stranger still. For beyond the end of suns, beyond the radiation that lashes from their deaths, lies the possibility that existence itself may not be stable. What if the universe harbours not only a timeline toward cooling, but a hidden trap in its very foundation, a false vacuum, a fragile state of reality that could collapse in an instant, rewriting the laws of nature themselves? The notion of fading stars suggests a slow decline, a universe dimming gently over uncountable ages. But there is another possibility, swifter, more terrifying, and invisible until it happens. Physicists call it vacuum decay. To understand it, one must step into the language of quantum fields, where reality is not emptiness, but a restless ocean. Particles are excitations of these fields, like ripples on a sea. Even the vacuum, the lowest possible state, is not truly empty, but filled with subtle energy. And in this structure lies a potential danger more absolute than any asteroid, more final than any supernova. The laws of nature, the constants that govern chemistry, biology, and even thought, may not rest on the most stable foundation. Instead, they may exist in what is called a false vacuum, a state that appears stable, but is not the ultimate minimum of energy. If so, then reality itself is balanced precariously, like a ball resting on a plateau. At any moment, a quantum fluctuation could allow it to slip into the true vacuum, the deeper valley of stability. Should this occur, a bubble of new reality would form, expanding at the speed of light. Inside the bubble, the laws of physics would be rewritten. Atoms might not hold together, stars might not ignite, molecules might never exist. Outside the bubble, nothing would seem amiss, until, without warning, the wavefront arrived, and everything was annihilated instantly. There would be no pain, no time to react, only the end of all structures, erased and replaced in silence. This is not science fiction, but a legitimate possibility drawn from the mathematics of quantum field theory. When the Higgs boson was discovered in 2012 at CERN's Large Hadron Collider, its measured properties suggested that our universe might indeed be metastable, perched precariously in a false vacuum, though the timescales are uncertain, perhaps billions or trillions of years. The very idea unsettles. It means the universe carries within itself a seed of destruction, not external, not cosmic, but intrinsic. The danger here is unlike any other. Asteroids can be tracked, supernovae anticipated, even black holes avoided at distance, but vacuum decay gives no warning. It is everywhere at once, and its horizon travels at the speed of light. A bubble could have already formed somewhere in the vastness of the cosmos, rushing silently toward us, its edge invisible until the moment of contact. In such a scenario, existence ends not with a bang or a fade, but with a quiet erasure, as though the universe had always been different. Some might argue that because the event is so unlikely in any given moment, it poses no immediate concern. But the peril is not only in probability, it is in perspective. To contemplate vacuum decay is to confront the possibility that reality is contingent, fragile, not ultimate. It undermines the sense of permanence, revealing that the ground beneath existence is itself uncertain. Philosophers find resonance here. If the universe is a false vacuum, then all meaning, all structure, all history is temporary scaffolding. Life itself becomes a flicker in a cosmos whose rules may at any time dissolve. To live under such a possibility is to live without guarantees, to recognize that permanence is an illusion. And yet, strangely, this recognition does not diminish wonder. It sharpens it. To know that the laws of nature are balanced on a knife's edge is to see each moment as extraordinary. Every breath, every star, every thought is happening against impossible odds. The fragility of reality itself becomes a kind of miracle, a canvas painted on fabric that could, at any time, be torn away. Some speculative physicists imagine what might lie beyond the bubble. Perhaps a new universe, stranger and harsher, where different laws govern, where matter as we know it cannot survive. Perhaps a reality where no structures form, where chaos rules, or perhaps a cosmos even more fertile, birthing new patterns of life and intelligence. These are conjectures only, for no observer could survive to report what comes after. Vacuum decay remains a danger not only of destruction, but of thought. It challenges human understanding, forcing us to admit that the universe may not be secure. It confronts the arrogance of permanence, humbling even the most advanced theories. In this way, it is as much a philosophical abyss as a physical one. But the universe is not exhausted of perils here. If vacuum decay reminds us that the laws of nature themselves can betray us, then another threat emerges from the opposite end. Not instability, but excess. For across the cosmos lurk energies so vast that they defy imagination. Bursts of radiation more powerful than any star, more sudden than any collapse. They are invisible until they strike, and when they do, entire atmospheres can be burned away. These are the gamma-ray bursts, lances of annihilation that streak across galaxies. They are among the most violent phenomena known, born from collapsing stars or merging neutron stars. If one were ever to aim directly at Earth, the planet's shield would fail in seconds, life reduced to memory. To move from the silence of vacuum decay to the fury of gamma-ray bursts is to realize that the dangers of the cosmos come not only from fragility, but from violence. Both the absence of law and its extremes threaten existence. And so the journey continues, threading between invisible abysses and radiant annihilation, between the fragility of vacuum and the fury of radiation. One danger dissolves reality from beneath, the other sears it from above. In the balance lies a fragile world, orbiting a fragile star, sheltered for now, but never beyond reach. The universe is filled with light, yet some of its most lethal weapons are invisible, travelling silently across the void. They strike without warning, altering matter at its most intimate level. If asteroids embody blunt force and black holes represent ultimate collapse, then cosmic radiation is a subtler assassin, an ever-present rain of energy that seeps into every corner of space. Its danger lies not in spectacle, but in persistence. Cosmic rays are high-energy particles, and mostly protons but also heavier nuclei, accelerated to near the speed of light by violent astrophysical events. Supernovae hurl them outward with the force of 1 billion suns. Pulsars, with their extreme magnetic fields, whip them across space in torrents. Even more mysterious are the rays of ultra-high energy, particles so powerful that they must have been launched by cataclysms beyond our current understanding, perhaps by active galactic nuclei, where supermassive black holes feed and spit out jets stretching across millions of light years. When these particles collide with Earth's atmosphere, they shatter into cascades of secondary particles, a storm of radiation that rains down on the planet's surface. Most are harmless at ground level, absorbed by air, water, and magnetic shielding. Yet their fingerprints are everywhere. Mutations in DNA, anomalies in electronic systems, faint isotopes locked in ancient rocks. Astronauts, however, are far less shielded. Outside Earth's magnetic cocoon, cosmic rays pose one of the greatest dangers to human exploration. Over long missions, the constant bombardment damages tissue, increases cancer risk, and may even impair cognition. Unlike solar flares, which can be predicted and shielded against temporarily, cosmic rays are constant, a background hazard woven into space itself. To journey to Mars or beyond is to walk beneath an invisible storm, one that no armour can fully deflect. The danger is not confined to life. Electronics too are vulnerable. A single high-energy particle striking a computer chip can flip a bit, altering calculations, disrupting navigation, or crashing systems. Engineers call these single-event upsets, but in deep space, they can mean the difference between survival and catastrophe. Every spacecraft carries within it the silent possibility of failure, seeded by rays born from stars long dead. There are deeper mysteries still. Some cosmic rays reach energies so extreme, 1 million times higher than those generated by human particle accelerators, that they defy explanation. Where are they born? How are they hurled to such velocities? Some theorists suggest exotic origins, the decay of hypothetical particles from the early universe, the tearing of space-time by cosmic strings, or collisions between relics of dimensions beyond our own. In their energy is encoded the possibility of new physics, but also the reminder that the universe can wield forces far beyond human comprehension. Yet cosmic rays are not purely enemies. Just as comets brought water and organics to the early Earth, radiation may have played a role in shaping evolution. Mutations, though often harmful, are also the raw material of change. The slow rain of particles from the stars may have altered genomes, nudging life along paths it would never otherwise have taken. In this sense, cosmic rays are double-edged, both destroyers and creators, weaving danger and possibility into the same fabric. Still, the peril remains undeniable. A nearby gamma-ray burst, even if not aimed precisely at Earth, could flood the solar system with such radiation that the ozone layer would be stripped away, exposing the surface to deadly ultraviolet rays from the sun. The fossil record offers tantalizing hints that past extinction events may have been triggered by such cosmic bombardments. Life's story, written in stone and bone, carries scars not only of earthly upheavals but of messages from distant stars. And beyond even bursts and rays there is a quieter menace: neutrinos. These ghostly particles, produced in vast numbers by nuclear reactions in stars and by supernovae, pass through matter almost unhindered. Trillions flow through every human body each second without resistance, without effect. Yet in rare interactions they leave traces. Neutrino observatories buried in ice or deep underground capture faint flashes of light when one finally collides with an atom. They are harmless in ordinary numbers, but their existence reminds us of the invisible flood that washes through all space, a reminder that even emptiness is never empty. Radiation, then, is the constant chorus of the universe. It can sterilize worlds, sculpt atmospheres, trigger extinctions. It can also spark transformations, nudging matter toward complexity. To live in the cosmos is to live immersed in this storm, protected only by thin shields of magnetism and atmosphere, temporary havens in a universe where energy flows without end. For humanity, the challenge is twofold. To survive beyond Earth, new forms of shielding must be imagined: magnetic bubbles, artificial atmospheres, or genetic adaptations. To understand the cosmos more deeply, new instruments must be built to track the highest energy particles, to decode the messages they carry from realms otherwise unreachable. In their silence lies knowledge, in their violence, peril. The paradox remains: cosmic radiation is both evidence of destruction and a whisper of creation. It burns and it shapes, it threatens and it teaches. But its constant presence forces a sobering recognition. Danger in the universe does not always arrive in sudden catastrophes. Sometimes it is steady, patient, ceaseless. Sometimes the killer is not the impact of a rock or the collapse of a star, but the endless rain of invisible fire, chiseling slowly at the edges of existence. And if invisible storms rain from the stars, what of the storms born closer to home? For our own sun, the giver of light and warmth, is not serene. Beneath its surface seethe tempests of plasma, eruptions of magnetism, flares and winds that lash outward through the solar system. If cosmic rays are the distant whispers of violence, then solar storms are its immediate thunder. They too are dangers, not of silence, but of suddenness, capable of burning the skies and silencing the machines upon which human civilization now depends. If cosmic radiation is the slow rain of the universe, then solar storms are its sudden lightning, violent, unpredictable, and close enough to touch us directly. The sun, viewed from Earth, seems serene, a golden disk steady in its glow. But beneath that calm surface, plasma churns in restless convection, magnetic fields twist and snap, and vast eruptions hurl fire into space. The same star that gives life also holds the power to disrupt or even extinguish it. Solar flares are among the most immediate expressions of this fury. They are sudden flashes of energy, the release of magnetic tension that builds as plasma knots beneath the sun's surface. In minutes, they unleash the power of billions of hydrogen bombs, blasting radiation across the solar system. The light arrives at Earth in just over 8 minutes, flooding the upper atmosphere with X-rays and ultraviolet rays. Astronauts caught unshielded in orbit would be exposed to lethal doses. Satellites, fragile in their electronics, can be blinded or crippled in an instant. Even more destructive are coronal mass ejections, immense clouds of charged particles hurled outward at millions of kilometers per hour. When such a cloud strikes Earth, it collides with the magnetic field that shields the planet. The field bends and crackles under the assault, driving currents into the atmosphere. The skies ignite in auroras, shimmering curtains of green and red that ripple across the poles. To the air they are beautiful, but beneath their glow lies danger. Electrical grids stretched across continents suddenly carry currents they were never designed to bear. Transformers explode, power lines melt, and darkness spreads across cities. History offers chilling reminders. In 1859, the Carrington event, the most powerful solar storm on record, set telegraph lines ablaze, shocking operators and sparking fires in stations. The aurora was seen as far south as the Caribbean, bathing the night in ghostly fire. Had such a storm struck today, with our civilization woven together by electronics, satellites, and global communication, the damage would be incalculable. Weeks, months, even years might pass before power grids and satellites could be fully restored. In a world dependent on technology, the sun itself becomes a weapon against us. Nor are these storms rare anomalies. Smaller but still dangerous events strike regularly. In 1989, a solar storm blacked out the entire Canadian province of Quebec within seconds. In 2003, a series of solar flares disrupted satellites and forced airlines to reroute flights to avoid radiation exposure at high latitudes. Each storm is a reminder that space weather is not a distant abstraction, but a force entwined with human survival. The peril extends beyond Earth. Future explorers on Mars or the moons of Jupiter will face solar storms without the protection of a strong magnetic field. A coronal mass ejection sweeping across their habitats could deliver radiation doses lethal within hours. Any vision of humanity's future among the stars must first reckon with the tempestuous nature of our own. Yet even as we prepare, our understanding is incomplete. Solar activity follows cycles, roughly 11 years in length, waxing and waning with sunspot counts. But the intensity of individual storms defies easy prediction. Models improve, satellites watch the sun constantly, but certainty eludes us. The star at the centre of our lives remains a mystery, its moods both essential and dangerous. And still, beyond storms and flares, the sun hides a deeper threat, its own mortality. In billions of years it will swell into a red giant, consuming inner planets, perhaps Earth itself. But long before that final act, subtle shifts in its output could alter our climate, destabilize ecosystems, and strain civilizations. Even a small change in solar luminosity, stretched over centuries, could rewrite the story of life. The sun is both nurturer and destroyer, a paradox embodied in fire. Ancient cultures worshipped it as a god, carving its face into stone, bowing to its rising each morning. Today, science strips away the myth, but reveals something no less awesome. A nuclear inferno raging at the heart of a star sustaining us, yet capable of undoing us with the flick of a magnetic lash. To live on Earth is to live at the mercy of this flame. Solar storms are reminders that danger need not come from the distant abyss of black holes or gamma bursts. It can rise from the very light that makes life possible. The skies above may glow with auroras, enchanting in their colours, but beneath their beauty lies the whisper of fragility, the recognition that our civilization rests on delicate circuits, vulnerable to a single tantrum from the sun. And so the gaze turns outward again, beyond the solar system, where stars far stranger than our own unleash perils more exotic still. For if the sun is a familiar fire, then there are suns that defy comprehension. Magnetars, neutron stars with magnetic fields so extreme that they warp atoms themselves. Their flares dwarf solar storms, their violence writes new chapters in the catalogue of cosmic threats. To look toward them is to realize that the universe holds storms far more deadly than any we have yet faced. If the sun reminds us of familiar peril, then magnetars represent the extreme, a danger so alien it borders on the incomprehensible. These are neutron stars, remnants of massive suns collapsed into spheres no wider than a city, but with magnetic fields 1,000 times stronger than ordinary pulsars. To speak of a magnetar is to speak of magnetism at its most violent, a force so immense it could erase data, distort atoms, and kill from across vast distances. A magnetar's field is measured in quadrillions of Gauss. By comparison, Earth's field is less than 1 Gauss, and even the strongest human-made magnets reach only tens of thousands. At such extremes, atoms themselves are warped, stretched into spindles by magnetic tension. If a magnetar were to appear as close as the distance from Earth to the Moon, it would wipe every hard drive on the planet and scramble every circuit instantly. Closer still, it could deform the very chemistry of life, tearing apart molecular bonds before flesh had time to feel pain. Magnetars reveal their presence through sudden, violent outbursts called star quakes. The crust of the neutron star, stressed by internal forces, cracks with a release of energy equivalent to 1 billion atomic bombs. In December 2004, such a flare from a magnetar 30,000 light-years away washed over Earth. Though distant, it saturated satellites, blinded detectors, and briefly altered our ionosphere. Had it been only a few thousand light-years closer, life on Earth might not have endured. Unlike supernovae, which announce themselves in brilliant light, magnetars hide in the shadows until they erupt. Their periods of calm lull the imagination, until a burst floods space with gamma rays. For civilizations like ours, dependent on electronics, communication, and fragile infrastructures, such a burst could reduce satellites to dead husks and plunge global systems into chaos. The beauty of auroras would give way to silence as the technological heartbeat of the world faltered. And yet, as catastrophic as their violence may seem, magnetars also serve as cosmic laboratories. Their extreme conditions push physics to limits unattainable on Earth. By studying their flares, scientists probe the nature of matter at densities greater than atomic nuclei, where neutrons themselves may dissolve into quark seas. Each observation is a glimpse of a regime that defies ordinary thought, where the known laws strain and fracture under pressure. Still, the peril is not abstract. Gamma-ray flares from magnetars could sterilize nearby planets, ending life before it had the chance to flourish. If Earth were unlucky enough to orbit close to one, evolution itself would have been erased. The galaxy may be littered with such sterilized worlds, barren because they were born too near magnetic monsters. This possibility casts a shadow over the search for life beyond Earth. Perhaps the silence of the cosmos, the great void revealed by radio telescopes, is partly explained by the violence of magnetars and their kin. Intelligent life may be fragile, too fragile to endure the repeated lashings of radiation in regions dense with neutron stars. The Fermi paradox, the haunting question of why we do not hear others, may find one of its answers in these stellar tyrants. There is poetry too in the idea that danger scales with rarity. Magnetars are few, only a handful known in our galaxy, yet their impact is profound. They embody the paradox of the cosmos. The rarest things often carry the greatest consequences. Just as a single asteroid ended the reign of dinosaurs, a single magnetar flare could one day write its name into the chronicle of human extinction. But the danger is not confined to magnetars alone. Other neutron star phenomena amplify the threat. Some neutron stars are part of binary systems, their gravity pulling matter from companions. As the material crashes onto the surface, it ignites thermonuclear explosions called X-ray bursts, flooding space with lethal radiation. Others spin so fast they become millisecond pulsars, whipping beams of energy across space like cosmic machine guns. To be caught in one of these beams is to be erased in moments. The deeper truth is that neutron stars, in all their forms, are reminders of the violence of stellar death. They are not anomalies, but natural outcomes, the corpses of suns that once shone brightly. In their compact silence, they carry both the memory of creation and the threat of destruction. Standing beneath the night sky, it is easy to see stars as pinpoints of serenity. Yet each light may be the birthplace of future ruin, destined to collapse and erupt into something deadly. The tranquility of starlight conceals a cycle of violence, birth, death, and aftershocks that ripple across galaxies. Magnetars are one such aftershock. Their bursts like cosmic heartbeats, irregular and devastating. And if the violence of magnetars speaks of stellar death, then another threat waits deeper still, phenomena not bound to stars at all but to the galaxy itself. For at the heart of the Milky Way lies a supermassive black hole, Sagittarius A, whose appetite shapes the motions of stars around it. It sleeps now, relatively quiet, but black holes can awaken. Jets of plasma, storms of radiation, eruptions of unimaginable scale. These too are dangers written into the architecture of galaxies. The story of cosmic peril is not finished with magnetars. They are one voice in a chorus of violence, a reminder that the universe holds dangers at every scale. From the collapse of stars to the silence of voids, from local storms to galactic upheavals. Each is a thread in a larger tapestry, woven from the paradox that creation and destruction are inseparable. And so, having glimpsed the wrath of magnetic monsters, the gaze turns toward the galactic centre, where shadows stir, and where danger takes the shape not of stars or storms, but of a sleeping giant whose hunger never ends. At the centre of our galaxy lies a darkness so vast that even light cannot escape. Sagittarius A, the supermassive black hole whose mass equals 4 million suns. It rests in the constellation Sagittarius, hidden behind veils of gas and dust, but its gravity sculpts the orbits of stars that dance frantically around an unseen master. For now, it appears quiet, a sleeping giant. Yet history and theory both remind us, such giants do not always sleep. Supermassive black holes are engines of destruction when awakened. As matter falls inward, it forms an accretion disk, a whirlpool of gas and dust spinning at nearly the speed of light. Friction heats the disk to millions of degrees, causing it to blaze brighter than entire galaxies. At the same time, magnetic fields twist into colossal jets, spearing outward for thousands of light years, emitting radiation across the spectrum. To live near an active galactic nucleus is to live in peril, bathed in lethal beams that sterilize worlds and strip atmospheres bare. Sagittarius A is dormant now, feeding only occasionally when a stray cloud or star wanders too close. But there are signs in the geological record that suggest it has flared in the past. Vast bubbles of radiation, stretching above and below the Milky Way, glow faintly in X-rays and gamma rays. They are scars of ancient outbursts, reminders that our galactic centre once roared with power. Should it awaken again with full fury, Earth, though distant at 26,000 light-years, might still feel the echo. Disrupted orbits of interstellar gas, storms of radiation sweeping across the spiral arms, signals that civilization would not survive unscathed. The danger is not limited to Sagittarius AE alone. Nearly every large galaxy harbours a supermassive black hole at its core, and when galaxies collide, as the Milky Way will one day collide with Andromeda, their central monsters may merge. Such an event would unleash gravitational waves strong enough to ripple across the universe, reshaping not only the galaxies themselves, but the very fabric of reality. Stars would be flung into intergalactic space, planetary systems shredded, and new jets of radiation would carve through the cosmos like lances of fire. There is also the danger of wandering black holes, intermediate mass bodies formed in the dense hearts of star clusters. Invisible except by their gravitational pull, they drift through galaxies as cosmic predators. A rogue passing near our solar system could disrupt the delicate balance of planetary orbits, sending comets raining inward, destabilizing Earth's path, even ejecting our world into the frozen abyss of interstellar night. No shield, no defense could prevent such a fate. And yet, the peril of galactic centers is not only physical, it is also existential. To contemplate Sagittarius A is to confront a mirror of destiny. Just as stars collapse into black holes, galaxies too are shaped by the hunger of central monsters. The history of the Milky Way is written in its dialogue with the beast at its heart, a dialogue of feeding and silence, of eruptions and calm. One day, perhaps, its hunger may shape the fate of our descendants, as surely as it shaped the galaxy's birth. Observatories like the Event Horizon Telescope have begun to capture the first images of these giants, their shadows framed by glowing gas. The sight is haunting, a ring of fire encircling an absence, a reminder that at the core of creation lies annihilation, and within that annihilation a paradox, for without supermassive black holes, galaxies might never form at all. Their gravity draws matter into spirals, their eruptions regulate star formation, their hunger carves the structures we call home. They are destroyers, yes, but also architects. This duality deepens the danger. For if black holes are necessary, then peril itself is woven into the fabric of existence. To erase them would be to erase galaxies, to erase stars, to erase the possibility of life. In this sense, Sagittarius A is not merely a threat that sleeps, it is the silent guardian of our galaxy, the dangerous parent that both nurtures and endangers its children. But one cannot ignore the possibility of awakening. Just as volcanoes sleep for centuries only to erupt in fury, so too can supermassive black holes. A single star torn apart in its jaws would release more energy than humanity has consumed in all its history. A steady stream of such meals would ignite Sagittarius A into a quasar, a beacon visible across billions of light years. And though distance may shield us from its direct beams, the storm would reshape the Milky Way in ways no civilization could endure. There are moments when astronomers speculate, could civilizations near other galactic centers ever survive? Or are their histories forever cut short, erased by the wrath of their central monsters? Perhaps this too contributes to the silence we hear when we listen for voices among the stars. Perhaps life blooms often, but rarely survives the awakening of its galactic parent. And yet, as with every peril, there is wonder. The same processes that could end us are also the keys to understanding reality itself. Black holes test the edges of physics, where gravity and quantum theory collide. They hold secrets of space-time, of dimensions beyond our own, of the possible birth of universes inside their collapse. To study them is to step closer to truths we have barely imagined. But the dangers of galactic centers are not the final word. Beyond the monsters at the heart of galaxies, the cosmos contains even stranger perils. For if black holes represent the collapse of matter, and dark energy the expansion of space, then there are forces that tear not from gravity or radiation, but from pure geometry, warps in the structure of the universe itself. These hypothetical entities, threads left from the dawn of time, may stretch across the cosmos, slicing through reality like blades. They are not stars, not planets, not holes, but scars from creation itself. If supermassive black holes are the titans that haunt galactic centers, then cosmic strings belong to an even stranger realm, relics of creation itself. They are not stars or planets, not even matter as we know it, but hypothesized defects in the fabric of space-time, scars left over from the universe's first fractions of a second. Imagine the cosmos in its infancy, a seething plasma of energy, hotter and denser than any star could endure. As it cooled, it underwent transitions like water freezing into ice. But just as ice can crack with imperfections, the universe too may have frozen with flaws. Those flaws are cosmic strings. Though never observed directly, their existence is predicted by some of the same theories that unify the fundamental forces of nature. A cosmic string would be unimaginably thin, narrower than a proton, yet its length could stretch across galaxies. Its mass per unit length would be so great that a kilometre of it could outweigh Earth. Passing near one would be like brushing the edge of a blade drawn across the cosmos. The danger lies in their gravitational pull. Though narrow, they would warp space around them, creating distortion so extreme that light itself would bend into duplicate images. If a string passed near Earth, its tidal forces could tear apart planets, stars, and entire systems. Worse still, strings could vibrate, snapping and reconnecting in bursts that release enormous amounts of energy, perhaps in the form of gravitational waves strong enough to ripple across the universe. To imagine a cosmic string cutting through our solar system is to imagine annihilation delivered in silence. There would be no warning, no flare of light, only the sudden disintegration of matter as gravity twisted and unbound it. Civilization would vanish in an instant, erased by a relic of creation older than galaxies. Yet strings may also lie beyond reach, scattered sparsely across the universe, invisible but real. If they exist, they may help explain mysteries of structure, how galaxies formed, why matter clusters as it does. In their peril is also knowledge, the chance to glimpse the universe's birth still written in its present. There are other scars too, hypothesized remnants of the Big Bang. Domain walls, vast two-dimensional sheets of energy dividing regions of space with different physical laws. Were Earth ever to drift into such a wall, the very constants of physics might shift. Electrons might orbit differently, protons might decay, chemistry itself could collapse. To exist in one domain is to live by one set of rules. To cross into another is to face unmaking. These are dangers not of familiar matter, but of geometry, of structure. They remind us that the universe is not only a stage for peril, but a source of peril in its design. To live is to trust that the cosmic fabric is smooth, stable, unbroken. But if the early universe left cracks, then existence itself rests on fragile foundations. What is most unsettling is the possibility that we might not detect these entities until too late. Cosmic strings could lurk invisible, their presence betrayed only by rare gravitational lensing events. Domain walls could be vast, stretching across regions of space larger than galaxies, and we might not know we approached one until its laws rewrote reality around us. Unlike asteroids or supernovae, these dangers offer no forecast. They are cosmic ambushes, relics of the first second of time. Philosophically, they pose another challenge. If strings or walls exist, then the laws of physics are not universal, but local. The constants that govern life, the charge of the electron, the strength of forces, the behavior of atoms, may be regional accidents. In another domain there may be no stars, no molecules, no life. The universe may be a patchwork quilt stitched from regions that cannot coexist. Our survival, then, is not only improbable, but precarious. For centuries humanity has sought permanence in the heavens. Stars seemed eternal, galaxies immutable, the sky a symbol of stability. But every step of discovery has revealed fragility instead. Stars die, galaxies collide, and even the laws of physics may be contingent. Cosmic strings and domain walls take this to its extreme, suggesting that the very fabric of reality may be temporary, unstable, prone to fracture. And yet, once again, danger and wonder intertwine. To discover a cosmic string would be to glimpse directly into the first heartbeat of the universe. To measure its vibration would be to listen to an echo from creation itself. The peril it carries is inseparable from the insight it offers. This, perhaps, is the deeper truth of cosmic danger. It is never only threat, but also revelation. Still, one cannot dwell long on the elegance of theory without confronting its implications. If a string snapped near us, the energy released could mimic the detonation of countless suns. If a wall passed through, atoms themselves would lose coherence. The fragility of our world would be laid bare not by distant explosions, but by the very fabric in which existence is woven. And if such relics exist, then the early universe was not gentle but turbulent, leaving scars like cracks in cooling glass. What else, then, might have survived from that primordial storm? Are there structures stranger still, hidden beyond detection, waiting for their moment to brush against us? The mind drifts from strings and walls to another form of danger, subtler but no less profound. The possibility that we're not alone, and that intelligence elsewhere may not be benign. If relics of creation remind us of physics beyond our control, then the prospect of alien civilizations reminds us of agency beyond our comprehension. Perhaps the silence of the stars is not emptiness, but caution, a warning unspoken. Cosmic strings and domain walls remind us that the universe itself can carry scars of creation, dangers written into its fabric. Yet another possibility haunts the imagination, one that does not come from blind physics alone, but from intention, from intelligence beyond Earth. The question of whether we are alone has lingered for centuries, whispered in myths, etched in telescopes, coded in signals that search the skies. To imagine other civilizations is to imagine other minds, and with them comes the realization that not all minds may be kind. The first danger lies not in invasion, but in perspective. The sheer scale of the universe suggests that life may exist elsewhere. Billions of galaxies, each with billions of stars, each with planets in abundance. The numbers stagger the mind. Yet the silence of the sky remains deafening. Radio telescopes listen, spacecraft search, but no signal has come that can be confirmed. This silence is what scientists call the Fermi paradox. If life is common, where is everyone? One answer is unsettling. Perhaps life is common, but intelligence is rare. Civilizations rise and fall swiftly, undone by their own instability, leaving only faint traces before silence returns. If so, then the danger is not from others, but from ourselves, a mirror of fragility written into the stars. But another possibility is darker. Perhaps civilizations exist, but remain hidden by choice. In a cosmos filled with predators, broadcasting one's presence could be fatal. The dark forest hypothesis, named for a haunting metaphor, imagines the universe as a silent forest. Each civilization is a hunter, moving quietly, wary of being discovered. To reveal one's position is to invite annihilation. If this is true, then the absence of signals is not a mystery but a warning. Silence is survival. The danger here is not abstract. Humanity has already begun to send its voice outward. Radio waves, television broadcasts, deliberate messages carried on spacecraft like Voyager. These signals radiate into space, announcing our presence to anyone listening. Perhaps no one hears, perhaps someone does. If they do, the intentions of those who hear remain beyond our imagining. Science fiction often portrays contact as either salvation or invasion, but reality may be stranger. A civilization millions of years older than ours would be as far beyond us as we are beyond insects. Their motives, their values, their perception of existence might be incomprehensible. To them, Earth might not be a treasure but a resource, not a partner but an obstacle. Even indifference could be deadly, as their tools, their technologies, their manipulations of energy might destroy us as an afterthought. Some thinkers imagine the opposite, that any civilization advanced enough to master the stars would have transcended violence. Yet history on Earth offers a sobering counterpoint. Intelligence does not erase competition, it refines it. Predators grow more subtle, not less. To assume benevolence is to gamble with existence. And yet danger may not come from physical arrival at all. A signal itself could be peril. Information, once received, cannot be undone. A message carrying knowledge beyond our understanding could destabilize society, overwhelm culture, or unleash technologies we cannot control. A virus need not be biological. It could be conceptual, a mimetic trap encoded in mathematics, a key that opens doors better left closed. The very act of listening carries risk. But silence is not safety either. If the dark forest hypothesis is true, then our broadcasts have already broken cover. Our presence has been announced, our light blazing in the forest of night. The question is not whether we will be noticed, but whether we already have been. The absence of evidence is no comfort. Space is vast, signals are faint, and civilizations may not use technologies we can detect. They may dwell in wavelengths we do not watch, or communicate in ways beyond electromagnetism. They may even exist as forms of intelligence woven into matter itself, too alien for us to recognize as life. In such a universe, danger may lie not in what is seen, but in what is unseen, overlooked because it is unimagined. There is another layer to this peril. If civilizations exist, their technologies may shape not just planets, but galaxies. Dyson spheres, hypothetical megastructures built around stars to harvest their energy, would be visible across light years, yet we see none. Does this mean they do not exist, or that they are hidden, cloaked, concealed? If the latter, then secrecy itself may be the greatest technology of survival. Humanity, naive in its openness, may be wandering into a forest where silence is the only law. Philosophically, the danger of alien intelligence is the danger of encountering something beyond comprehension. To meet another mind is to risk losing our own frame of meaning, our assumptions about uniqueness, our illusions of centrality. Just as Earth was once dethroned from the centre of the cosmos, so too might humanity be dethroned from its place as solitary intelligence. And with that dethronement may come fear, awe, or obliteration. And yet, as with every cosmic danger, there is also wonder. The possibility of others reminds us that the universe may not be empty, but alive with stories untold. The same fear that warns us to stay silent also urges us to listen, to seek, to imagine. In that tension lies the deepest paradox of exploration, the hunger for connection, and the terror of what might be found. From the silence of the stars, the gaze returns to our own fragile planet, for there are dangers not only from without, but from within. Cosmic hazards may one day end life, but so too might the very conditions of Earth itself: shifting climates, restless geology, fragile atmospheres. The peril is not only written in galaxies, it is also etched in the soil beneath our feet. If alien civilizations represent the danger of intelligence beyond our control, then Earth itself embodies a quieter but ever-present peril. For the same forces that shape this world into a cradle of life are restless and volatile, capable of turning against their creation without warning. To look outward at cosmic threats is to forget sometimes that danger also rises from beneath our feet and from the skies that surround us. The planet's atmosphere, so thin it would fit into a painter's brushstroke against the scale of Earth, is both shield and vulnerability. Within it, climate shifts have triggered mass extinctions. Ancient ice ages buried continents under frozen silence, while episodes of warming suffocated seas and left them barren. These events were not caused by humanity, though humanity now accelerates similar changes. They were born of Earth's chaotic dance with the cosmos, the tilt of its axis, the wobble of its orbit, the pulses of the sun. Life survived each time, but not without loss. Entire kingdoms of creatures vanished, their bones sealed in stone as testimony to the instability of the world. Volcanoes, too, are reminders of planetary restlessness. Beneath the crust lies a sea of molten rock, circulating slowly, waiting for release. When supervolcanoes erupt, the effects are not local, but global. The eruption of Toba in Indonesia nearly 74,000 years ago cloaked the sky in ash, reducing global temperatures and driving humanity itself to the brink. Yellowstone, sleeping now beneath the plains of North America, has erupted many times in its ancient past. If it awakens again, skies could darken for years, crops could fail across continents, and civilization as we know it could unravel. Earthquakes arise from the same tectonic restlessness, sudden lurches as plates grind and slip. Most are survivable, deadly only in cities, but the largest reshape landscapes in hours, raising mountains, sinking coastlines, and unleashing tsunamis that roar across oceans. In such moments, the planet reminds its inhabitants that they do not command but borrow their place. Even the oceans carry dangers. Currents, driven by temperature, salt, and wind, form a circulatory system for the planet. If disrupted, climates shift violently. During the last ice age, a sudden release of glacial meltwater into the Atlantic slowed its great current, plunging the northern hemisphere into centuries of cold. Were such a disruption to occur again, Perhaps from the rapid melting of Greenland today, the balance of seasons could collapse, transforming fields into deserts and cities into tundra. These are dangers older than humanity, indifferent to civilization's rise. Yet humanity adds its own layer, amplifying risk. Industrialization pours greenhouse gases into the sky, warming the planet at a pace unseen in geological history. This warming alters storms, melts ice, and raises seas. The danger is not simply environmental but existential. Food systems falter, coastlines drown, migration strains societies, conflicts sharpen. For the first time, Earth's peril is entwined with its dominant species. There are other threats, rarer but no less real. Asteroids from beyond, already considered, may still strike, but smaller fragments strike often, igniting skies with fireballs, shaking forests with shock waves. A larger one, unnoticed until it is too late, could fall tomorrow, reshaping history in an instant. The planet's surface bears countless craters, scars of a sky that has always been armed. Biology itself carries peril. Pandemics sweep through species, sometimes erasing entire populations. Humanity has felt this repeatedly, but viruses and bacteria evolve constantly, waiting in reservoirs among animals. In an interconnected world, a new pathogen can circle the globe in days. Such dangers are not cosmic, yet they are universal, the fragility of life itself, mirrored on countless worlds across the galaxy. The deep truth is that Earth is not a safe harbour in a dangerous universe. It is part of the danger, a world both nurturing and destructive. To live here is to live on shifting ground, beneath volatile skies, beside oceans that remember ancient floods. Civilization builds towers and satellites, but beneath them the crust trembles, and above them the air grows restless. Philosophically, this recognition is humbling. Humanity often imagines itself as fragile only in the face of distant catastrophes. Asteroids, black holes, alien mines. Yet the greatest dangers may be those nearest, those we mistake for stability. The soil beneath us, the air around us, the seas we cross. Each is a gift, and each can turn. And still, paradox rules. These same forces that threaten life also sustain it. Volcanism replenishes soils, tectonic cycle nutrients, storms redistribute heat, climate shifts drive evolution. Even extinction clears space for renewal, as it did after the dinosaurs' end, opening a path for mammals to rise. Danger and creation remain inseparable, woven into the same cycle. Yet danger is not bounded by Earth alone. Beyond our planet, the solar system itself carries risks hidden in its architecture. The outer giants, Jupiter, Saturn, Uranus, Neptune, shepherd comets and asteroids, sometimes protecting Earth, sometimes hurling debris inward. Jupiter, with its immense gravity, has been called both guardian and executioner, deflecting some threats while amplifying others. The same planet that shields us may one day send a frozen bullet toward us. And what of the Sun's siblings? Stars born from the same nursery as ours, now scattered across the galaxy. If one passes too near, its gravity could disturb the Oort cloud, sending a storm of comets inward. Such stellar encounters have happened before, written in the slow dance of orbits. The next may already be approaching. Thus, the peril of Earth is never only Earth's own. It is entangled with the solar system, with galactic tides, with forces larger than any horizon. To imagine safety is to forget that the planet is only one node in a network of risks stretching across light years. And so, having looked inward to our fragile home, the gaze must expand again. For if planets and stars carry dangers, then the space between them, the interstellar medium, holds threats of its own. Invisible clouds of dust, radiation fields, and drifting rogue planets wander there. To journey outward is to enter an ocean not only vast, but filled with hazards unseen, waiting between the stars. The solar system feels familiar, charted by centuries of astronomy, mapped by robotic probes, its planets photographed in detail. Yet beyond its orderly circles lies a wilderness, the interstellar medium, the dark sea between stars. To enter it is to leave behind the protection of the sun, to cross into an ocean where even emptiness becomes a threat. At first glance, interstellar space seems safe. Its density is lower than the best vacuums humans can create in laboratories, nearly empty. But in truth, it is a realm filled with dust, gas, and radiation, each carrying dangers invisible to the eye. Cosmic rays here are more intense, no longer buffered by the sun's magnetic field. Every particle strikes like a bullet, gradually eroding materials, frying electronics, and tearing at DNA. To cross this sea is to endure a slow storm without shelter. There are also clouds of interstellar dust, diffuse yet vast. When the solar system drifts into one, the dust can dim the sun's light, cooling Earth in subtle but devastating ways. Geological records hint at past encounters, drops in temperature, disruptions in climate, extinctions whispered into stone. One such cloud, dense enough, could reduce sunlight by half for millennia, freezing oceans and burying continents in ice. Life, as fragile as flame in wind, might dwindle to embers. Rogue planets add another layer of peril. Formed in stellar nurseries but flung free by gravitational encounters, they wander the galaxy unbound. Dark, frozen, and numerous, they drift invisibly between stars. Should one pass near the solar system, its gravity could distort planetary orbits, hurling comets inward or tugging Earth from its delicate balance. Worse still, a direct collision, though improbable, would be annihilation absolute, a planet striking planet, an impact erasing history in a moment of fire. The interstellar medium also hides dangers more exotic. Shock fronts from ancient supernovae still ripple outward, shells of gas that sweep through space at hundreds of kilometers per second. To drift into such a front would be to face a tide of radiation and particles, a hazard no shield could deflect. Even the faintest echoes of these blasts, when they wash over Earth, can alter atmospheres, changing chemistry in ways that ripple through ecosystems. But perhaps the most profound danger of interstellar space is isolation itself. Once beyond the sun's protective bubble, the heliosphere, a spacecraft, or a future crewed vessel, is exposed. Communication lags stretch into hours, then days, then years. Power must be generated without sunlight. Navigation must be precise in a darkness where stars shift only slowly. To drift too far, to miscalculate, is to be lost forever, vanishing into the silence between suns. Voyager. Xian, humanity's most distant emissary, has already crossed this threshold. Its instruments, though faint, still whisper back across billions of kilometers. But even this machine, built with care and purpose, will one day fall silent, swallowed by the dark. It carries a golden record, inscribed with sounds and images of Earth. Greetings in many languages, the heartbeat of a mother, the music of Bach. Whether anyone will ever find it is uncertain. In the interstellar medium, objects can drift unseen for eons, their trajectories altered by faint pulls, their destinies unknowable. And what of life in such places? Rogue planets, though cold, may hide oceans beneath thick ice, warmed by internal heat. Some scientists speculate that such worlds could host microbial ecosystems, sealed away from starlight, evolving in isolation. If so, then the interstellar medium is not only dangerous but alive, scattered with hidden sanctuaries drifting between suns. The paradox deepens. Even here, in peril and cold, creation may persist. The philosophical danger of interstellar space lies in its scale. To journey outward is to confront distances so vast that even light, the universe's swiftest messenger, takes centuries to cross them. Civilization is bound to time as much as to space. A generation ship setting sail might never reach its destination before its mission dissolves into forgetfulness. What begins as exploration could end as exile, a people adrift in endless night, no longer remembering why they left. Thus, the interstellar medium is not merely a place but a trial. It strips away certainty, protection, memory. It forces life to endure without guarantees, to persist in a darkness where danger comes not only from radiation or collision, but from despair. The peril here is psychological as much as physical. The weight of silence, the absence of familiar stars, the knowledge of being utterly alone. And yet, humanity will go. Curiosity has always driven ships across oceans, deserts, and voids. To reach another star, to touch another world, the interstellar medium must be crossed. Its dangers, though immense, are part of the price of discovery. The question is not whether we will face them, but how. Will technology invent shields against radiation, engines to shorten journeys, habitats that preserve memory? Or will the interstellar dark remain an uncrossable frontier, a reminder that the universe does not yield easily? Even as these thoughts unfold, another layer of peril waits beyond, for the galaxy itself is not static. It drifts, it collides, it evolves. Stars are born and die. Arms of spirals twist and shear. The Milky Way is a living structure, restless across eons. And in that restlessness lies a future danger more immense than any single storm or flare. The inevitable collision between our galaxy and its nearest neighbour, Andromeda. When galaxies collide, the stage of danger expands beyond planets and stars. The architecture of the cosmos itself becomes a battlefield, and one day, billions of years from now, Earth, if it still circles the Sun, will witness the sky split by the approach of another spiral, vast and luminous, carrying both wonder and doom. The Milky Way, with its spiral arms and billions of suns, feels to us like a stable island in an endless sea. Yet even galaxies are not eternal havens. They drift through the cosmos like ships on invisible currents, drawn together by gravity, colliding in slow-motion cataclysms that last billions of years, and the fate of our own is already written. The Andromeda Galaxy, our nearest spiral neighbour, is on a collision course with the Milky Way. In roughly 4 billion years, the two will meet in an event that will reshape the night sky, and perhaps erase the conditions for life on Earth. The scale of such a collision defies imagination. Galaxies are mostly empty space. Stars are so far apart that direct collisions are rare. When the spirals merge, most suns will sail past one another without contact. But gravity will weave chaos. Orbits will warp, clusters will scatter, and some stars will be flung into the abyss between galaxies. Entire planetary systems may be torn from their cradles, left to wander as orphans in the intergalactic dark. For Earth, the danger is not that it will strike another star, but that its orbit will be altered. A shift in the sun's path could destabilize the solar system, sending planets into eccentric trajectories or hurling comets inward in storms unseen since the age of dinosaurs. The sky will change long before that. As Andromeda approaches, it will swell to fill the heavens, a ghostly spiral rising beside the Milky Way, until the two interlace in a spectacle of unimaginable grandeur. The night will blaze with light, but beauty will mask peril. At the heart of each galaxy lies a supermassive black hole. When the Milky Way and Andromeda merge, these giants will spiral inward, radiating gravitational waves until they collide in a final eruption of power. The merger will send shockwaves across space-time, warping the very fabric of the universe. The resulting black hole will be larger still, a titan millions of times the mass of the Sun, anchoring the new galaxy that emerges from the wreckage. Its eruptions, its jets of energy, may sterilize vast regions, burning out nascent worlds before they can nurture life. Astronomers call the merged galaxy Milkomeda, a single elliptical system born of violence. From its perspective, billions of years hence, the night sky will be different. Other galaxies, driven away by dark energy, will have vanished beyond the horizon of visibility. To the beings who might look up then, if any remain, the universe will appear smaller, emptier, lonelier. They will not see the vast web we see now. The cosmic story will seem to end with their own galaxy. Yet this collision, like so many cosmic perils, carries paradox. It is destruction, but also creation. The turmoil of merging galaxies will trigger waves of star formation as clouds of gas collide and collapse. New suns will be born, perhaps with new worlds, perhaps with new chances for life. The same event that may end our history could begin countless others. But to beings alive during the collision, should Earth or its descendants endure, the danger is immediate. Radiation storms, gravitational disruptions, cometary bombardments, each would test the resilience of civilizations. Technology might defend against some, but not all. There is no shield against the scale of galaxies colliding. The only certainty is change, written in the motions of stars since the beginning of time. Beyond the Milky Way and Andromeda, such collisions happen constantly. Telescopes have captured galaxies mid-embrace, their spirals torn into streams of stars, their cores glowing with bursts of activity. Each image is a window into our own future, a reminder that even galaxies live and die. The universe is not a serene expanse, but a stage where giants clash endlessly, shaping the destiny of stars and worlds. And what of Earth in this distant future? By the time Andromeda arrives, the sun itself will be nearing the end of its life, swelling toward its red giant phase. Whether Earth still orbits then, or whether it has already been consumed, is uncertain. If it survives, the collision may doom it anyway, sending it adrift or bathing it in deadly radiation. If it does not, then life will already be gone, erased not by galactic tides, but by the death of its star. Philosophically, the collision of galaxies expands the scale of peril to its widest yet. No longer is danger tied to rocks or stars, but to the architecture of the cosmos itself. Even galaxies are temporary, transient forms in a universe governed by motion. To recognize this is to understand that nothing, not even the grandest structures of creation, escapes change. Yet in that recognition lies awe. To imagine the sky ablaze with two spirals merging is to imagine a spectacle few could see, a beauty so immense it borders on the divine. Danger and wonder, once again inseparable. The universe writes its story in both, forcing us to accept that peril is not a flaw but a feature of existence. And still, beyond even galactic collisions, other dangers wait. For the universe is not only sculpted by gravity and matter, but also by time itself. The arrow of time drives entropy, eroding order, scattering energy, leading inevitably toward heat death. But there are other possible endings, stranger and swifter. The collapse of space, the tearing of dimensions, the sudden unravelling of everything. Beyond the slow violence of merging galaxies lies the possibility of an ultimate doom, the death of the universe itself. The collision of galaxies is a spectacle of gravity, but the universe's deepest peril may not come from motion at all. It may come from endings written into the very laws of physics. For while stars collapse, black holes merge, and galaxies collide, the cosmos itself moves toward a fate. The question that haunts cosmology is not whether the universe will end, but how. The most familiar vision is heat death, a future where energy spreads so thin that no structure remains. Stars burn out, black holes evaporate, and even particles decay into radiation. The cosmos cools to near absolute zero, a silent desert where nothing stirs. This scenario unfolds not in fire but in frost, not in collapse but in endless expansion. It is annihilation by dilution, the erasure of all difference. But heat death is not the only possibility. Another, more violent, is the Big Rip. If dark energy, the mysterious force accelerating cosmic expansion, grows stronger over time, then space will not only stretch galaxies apart but eventually tear everything down to the smallest scale. First, galaxies drift away until none are visible. Then stars are pulled from galaxies, planets from stars. Finally, atoms themselves are torn apart, ripped open as the expansion overwhelms the forces that bind them. Time ends in fragmentation, space dissolves into chaos. The Big Rip could occur in tens of billions of years, or sooner, if dark energy shifts unpredictably. There is also the Big Crunch, the mirror opposite. If dark energy were to weaken or reverse, gravity might one day halt expansion and pull everything back together. Galaxies would converge, stars would collide, temperatures would rise until the cosmos collapsed into a singular fireball. The end would resemble the beginning, all matter compressed into a single point, perhaps to explode again in another big bang. In such a cycle, universes might be born and die eternally, each one forgetting the last. And then there is the strangest possibility of all, vacuum decay, already whispered in earlier chapters. If our universe is metastable, perched in a false vacuum, it could collapse into a lower energy state at any moment. The transformation would rewrite the laws of physics themselves. Molecules would not form, light might not travel, time itself might unfold differently. Existence, as we know it, would end instantly and absolutely, replaced by a reality unrecognizable. Each of these endings carries danger not only of destruction but of meaning. To imagine heat death is to imagine futility, all stories dissolving into silence. To imagine the Big Rip is to imagine terror, everything torn apart in accelerating frenzy. To imagine the Big Crunch is to imagine inevitability, the return to the fire that birthed us, and to imagine vacuum decay is to imagine fragility, that everything is temporary, held together by chance. The universe does not reveal which fate awaits. Its expansion is measured, its energy mapped, but uncertainty remains. Perhaps dark energy is constant, perhaps it shifts. Perhaps we live in one cycle of many, perhaps we are unique. Science peers forward with equations, but the horizon of billions of years is clouded with mystery. The future is as uncertain as the birth was, a riddle bracketed by silence. For humanity, the timescales are beyond relevance. Civilizations rise and fall in thousands of years, species in millions, planets in billions. Yet to contemplate these ends is not meaningless. It is to glimpse our place in a story far larger than ourselves. It is to feel awe at the fragility of life against the backdrop of infinite time. To know that the universe will one day end is to value more deeply the brief light we hold. And still, the mind cannot help but wander further. What if these endings are not endings? What if the Big Crunch births another Big Bang, a new universe seeded from the ashes of the old? What if the Big Rip fragments space into patches, each forming new realities? What if vacuum decay is not destruction but transition, a doorway into something else? In each doom lies the whisper of renewal, though not for us, not for what we know. Philosophically, these fates press upon the oldest questions. Is meaning possible in a cosmos destined for silence? Does creation matter if it is temporary? Perhaps the answer is in the act of knowing, in the brief consciousness that can glimpse eternity even as it vanishes. The danger of the universe's death is not only extinction but despair. Yet to face it with wonder is to turn peril into perspective, to see fragility as miracle. And so, from galaxies colliding to universes ending, the scale of danger has reached its widest horizon. Beyond planets, beyond stars, beyond galaxies themselves, lies the possibility that everything, every particle, every law, will one day dissolve. But the catalogue of perils is not yet complete. For within the present universe, before its distant death, other threats loom more immediate, more intimate. Dangers not of vast timescales, but of moments, bursts of radiation, wandering stars, unseen rocks that may strike tomorrow. The next danger is not billions of years away, but already woven into the sky above, fast, invisible, and capable of striking without warning. They are smaller than galaxies, smaller than stars, yet their violence can end worlds. They are the killers of planets, the messengers of extinction, the gamma-ray bursts. If the end of the universe is written in time, then gamma-ray bursts are written in fire, sudden, ferocious, and devastating on scales that dwarf imagination. They are the most luminous explosions known, outshining entire galaxies for a few fleeting moments. To encounter one is to stand before a weapon forged by collapsing stars, a lance of energy so concentrated it could erase a biosphere in seconds. Gamma-ray bursts, or GRBs, come in two main kinds. The long bursts are born from the deaths of massive stars, collapsing into black holes and unleashing jets of radiation that pierce the cosmos. The short bursts emerge from collisions between neutron stars, events that also flood the universe with heavy elements: gold, platinum, uranium. In either case, the physics is the same: relativistic jets, particles accelerated to near light speed, beams so narrow they carve through space like blades. What makes GRBs truly dangerous is their precision. They are not spheres of destruction spreading evenly in all directions. They are focused, directional, like searchlights turned into weapons. If Earth were ever caught in one, the consequences would be swift and total. The upper atmosphere would ionize instantly, ozone would vanish, and the planet's surface would be scalded by ultraviolet radiation from the sun. Ecosystems would collapse, food chains would break, and extinction would sweep across continents. Some scientists speculate that such an event may already have scarred Earth in its past. The Ordovician mass extinction, roughly 450 million years ago, coincided with signs that the ozone layer thinned rapidly. While volcanic activity and climate change may have played roles, a gamma-ray burst has been proposed as a trigger, a silent beam from across the galaxy that reset the course of life. The odds of a direct hit are small, for space is vast and beams are narrow, yet the danger cannot be dismissed. GRBs occur daily across the observable universe. Somewhere, every day, a star dies, or two neutron stars collide, and for a brief instant, a beam of annihilation sweeps outward. That none have struck us recently is not evidence of safety, only of fortune. The universe does not play favourites, and the Earth is not exempt from its crosshairs. GRBs reveal another unsettling truth. The galaxy itself is not uniformly safe. Regions dense with star formation, rich in massive stars, are breeding grounds for bursts. Perhaps life is rare not because it cannot form, but because it cannot survive long in such regions. Worlds orbiting young suns may bloom with biology, only to be sterilized repeatedly by bursts from neighbors. In this way, GRBs may shape the very distribution of life, pruning the cosmos ruthlessly, leaving only those in calmer regions, like our solar system, is the chance to endure. But endurance is not permanence. Astronomers have identified potential progenitors, stars large enough, unstable enough, to collapse into GRB engines. One such candidate is Eta Carinae, a luminous giant more than 100 times the mass of the Sun. When it dies, it will explode with violence beyond comprehension. Fortunately, its beam, if it forms, is unlikely to aim at Earth. Yet, unlikely is not the same as impossible. The paradox deepens. GRBs destroy, yet they also create. Their collisions forge the heavy elements upon which civilizations depend. Without them, there might be no gold in veins of rock, no uranium to split in reactors, no platinum in circuits. They are both executioners and alchemists writing extinction and creation with the same fire. In their duality, they echo the paradox of the universe itself. From a philosophical lens, GRBs embody the danger of indifference. They carry no intent, no malice, no warning. They are pure consequence, the unavoidable outcome of physical laws operating at extremes. To be erased by a burst is not to be targeted, but to be incidental, collateral in the mechanics of stars. There is a kind of terror in this, that existence can end not by design, but by accident, a beam from across the galaxy sweeping over Earth in silence. And yet, just as with other perils, science turns danger into insight. By studying GRBs, astronomers probe the lives of massive stars, the nature of neutron star mergers, the birth of black holes. Satellites orbiting Earth watch for bursts, their instruments ready to record in seconds what cannot be predicted. Each detection is a chance to learn, to transform catastrophe into knowledge, though always with the awareness that one day a detection may be too close, too late. The universe is restless, and GRBs are among its fiercest expressions. To know they exist is to accept that safety is never absolute, that life survives not by right but by chance. We orbit a star in a quiet arm of the Milky Way, far from stellar nurseries where bursts are common, but orbits change, arms shift, and time stretches long. In billions of years, even quiet regions may grow perilous. The threat never disappears, it only waits. And if the sky can burn with beams, what of the storms that linger unseen, the backgrounds that fill all space? For even when no bursts strike, Earth is bathed constantly in radiation, a diffuse afterglow from countless events, the relic fire of creation itself. The cosmic microwave background whispers of the Big Bang, while high-energy backgrounds hint at galaxies colliding, black holes feeding, bursts erupting in distant night. To live in the cosmos is to be surrounded by invisible fire, sometimes concentrated, sometimes diffuse, but always present. And beyond even these bursts lies another danger, subtler but perhaps more insidious, the collapse not of stars but of stability itself. The laws of physics may not be fixed, constants may shift, symmetries may break. If GRBs remind us of fire, then the shifting of laws reminds us of fragility. For if the universe can rewrite its own rules, then danger may come not from outside but from within reality itself. If gamma-ray bursts embody annihilation by fire, then the instability of physical law itself represents a danger far stranger, a threat not of explosions or collisions, but of the very stage upon which reality is built. For science assumes that the laws of physics are universal and unchanging. The speed of light, the charge of the electron, the strength of gravity. These constants are the foundation upon which atoms bind, stars shine, and minds think. Yet what if they are not constant at all? Some cosmological models suggest that physical constants may vary over time or space. Subtle shifts in the fine structure constant, which governs how electrons orbit nuclei, have been hinted at in spectral lines from distant quasars. If true, then the physics we know may be only local, temporary, contingent. Even a change of one part in a million could unravel chemistry. Stars might not burn, molecules might not form, DNA itself could dissolve into incoherence. Life is not only fragile against rocks and radiation, it is fragile against the possibility that the universe may simply decide to play by different rules. The danger here is existential. For if constants can drift, there is no defense, no shelter. Technology cannot shield against a shift in the laws of nature. It would be as if the grammar of reality were suddenly rewritten, rendering all meaning incomprehensible. A star could continue shining one moment and vanish the next, not by explosion, but because the physics that allowed it had evaporated. Philosophers find resonance here with ancient myths of unstable gods and shifting worlds. To live in a reality whose laws are mutable is to live without foundation, to inhabit a dream that may dissolve. The terror is not of violence but of impermanence, not of death but of the erasure of context itself. And yet if constants vary, they may do so slowly across billions of years. Perhaps the universe is tuned not to stability but to flux, a cosmos always in motion even at its deepest level. If so, then life exists only in rare windows when the rules align to permit it. In that case, our existence is not only improbable but fleeting, a spark between shifting states. The possibility of variable constants also touches the multiverse hypothesis. If reality is one bubble among many, each universe may carry its own set of rules. Some may collapse instantly, others may be barren, Others may flourish with structures unimaginable. Our universe may simply be one of the rare ones where the constants happen to align for complexity. If so, then danger lies not only in external threats, but in the possibility that our bubble may pop, replaced by another where life is impossible. Such thoughts are not purely speculative. Particle physics itself hints at instability. The Higgs field, which gives particles their mass, may not be in the most stable configuration. If it decays, as discussed earlier with the false vacuum, the entire structure of matter would be rewritten. What we call constants may only be temporary solutions, placeholders for deeper dynamics. To imagine this is to imagine a cosmos always on the edge of transformation, each moment provisional, each law negotiable. It is a vision both terrifying and sublime. Terrifying because permanence vanishes, sublime because it reveals the universe as more alive, more dynamic than any machine. And yet, while constants may shift across eons, there are perils far more immediate within the same domain. For alongside physics lies another frontier, the nature of time itself. We move through it as though it were a river, one-directional, unstoppable. But physics does not demand this arrow. At the fundamental level, equations run both forward and backward. Entropy, the tendency of systems toward disorder, gives time its direction, but entropy itself is not eternal. Some theorists imagine scenarios in which time could reverse, collapse, or fracture. What would it mean for time to break? If entropy were to reset, if the arrow of time bent backward, memory itself would dissolve. Cause and effect would unravel, events would no longer follow one another, and consciousness, so bound to sequence, would evaporate. For life is not only matter in motion, it is matter moving through time. Without time's arrow there is no growth, no story, no self. In this sense, the danger of shifting constants and unstable time is not only extinction, but incomprehensibility. It is not just that life could end, but that the very framework in which life makes sense could collapse. It is annihilation of meaning as much as matter. Yet once again the paradox arises. Danger and wonder are inseparable, for if constants can shift, if time itself can bend, then the universe is stranger than we can imagine, more creative, more alive. Perhaps these instabilities are not flaws but pathways, openings to new realms, new physics, new forms of being. Perhaps what looks like danger from within is transformation from without. Still, for humanity in its fragile moment, the threat is real. A cosmos where constants drift and time may falter is not a safe stage. It is an abyss beneath our feet, invisible yet ever present. We build civilizations on assumptions of permanence, but permanence itself may be an illusion. And so, from gamma-ray bursts that sear planets to shifting laws that dissolve reality, the spectrum of danger widens. It stretches from the violence of stars to the fragility of existence itself. And yet, beyond even these lies another category of peril. Not fire, not physics, but silence. For the universe is vast, and in its vastness, loneliness itself may be the greatest danger of all. If shifting constants threaten existence by dissolving its framework, then cosmic loneliness threatens in another way, by dissolving meaning. The universe is immense, scattered with galaxies, each filled with billions of stars, each star circled by planets. The mathematics suggests abundance, and yet the silence of the skies persists. Radio telescopes sweep the heavens, spacecraft drift outward with messages, but no reply comes. This silence is not neutral, it is heavy, unsettling, and dangerous in its implications. One possibility is that humanity is alone, not just in the galaxy, but in the entire observable universe. If so, then Earth is not merely rare, it is unique. Life has arisen only here, consciousness only here, and the burden of awareness lies solely on this small world. At first glance this might seem a gift, but solitude on such a scale is perilous. Without others, There are no teachers, no companions, no reminders that survival is possible. If we fail, the story ends entirely. The silence in this reading is responsibility amplified to unbearable weight. Another possibility is darker still. Life is common, but intelligence destroys itself. Civilizations may rise and burn brightly, but they do not last. They build tools too powerful, destabilize their own environments, or fall to conflicts they cannot resolve. If this is true, then the silence is not emptiness, but a graveyard. We are hearing not the absence of voices, but the aftermath of extinction. The danger then is not distant, but immediate. We may be walking the same path, another echo in the cosmic pattern of failure. The Great Filter hypothesis sharpens this fear. Somewhere between the origin of life and the expansion of civilizations into the stars lies a barrier, a filter so difficult to pass that almost none succeed. Perhaps the filter is behind us, in the improbable chemistry that birthed the first cell. If so, we are rare survivors, but perhaps the filter is ahead of us, in challenges we have not yet overcome. Nuclear weapons, climate collapse, artificial intelligence, pandemics. These could be the trials that silence civilizations. If the filter is in our future, then peril is not theoretical but imminent. Yet silence can also hide intention. The dark forest hypothesis, already whispered before, imagines the galaxy as a place where survival demands quiet. Each civilization knows that others may exist, but cannot predict their motives. To broadcast one's position is to risk annihilation by a cautious or hostile neighbour. In such a forest, silence is camouflage, and the absence of signals is not emptiness but fear. If this is true, then humanity, with its radio waves leaking into space, has already broken cover. We are the naive hunters calling out in the dark. The danger here is profound, for if others listen, they may not be benevolent. Intelligence does not guarantee morality. Technology does not guarantee wisdom. To beings millions of years older, we may appear as resources, curiosities, or threats. They may not need to visit at all. A signal, encoded with destructive instructions, could unravel us from within. A gift of knowledge could be poison disguised, a trap that collapses civilization. Philosophically, loneliness and contact mirror one another. To be alone is terrifying. To meet another may be worse. Both possibilities are perilous, and both haunt the silence of the sky. Humanity stands suspended between them, uncertain whether to hope or fear. The question is not whether life exists, but whether survival is possible in a universe filled with both violence and fragility. There is yet another possibility, that signals exist, but we cannot recognize them. Perhaps other intelligences communicate in forms we cannot detect. Neutrinos, gravitational waves, or even patterns written into the fabric of space-time itself. They may dwell at scales too vast or too subtle for us to perceive, like organisms unaware of galaxies. In that case, danger lies not in absence but in blindness. We may be surrounded by voices, deaf to their warnings, oblivious to their presence. This loneliness is not only cosmic but psychological. To contemplate an empty universe is to confront insignificance. Civilizations crave context, narratives that place them within larger stories. Without others, humanity risks turning inward, collapsing into despair or arrogance. Both are dangers. Despair may paralyze, arrogance may destroy. In silence, meaning erodes, and survival itself becomes uncertain. Yet as always, danger and wonder intertwine. For if we are alone, then our existence is more precious. Every thought, every song, every child born on earth is a miracle against infinite odds. If others exist, then we are part of a larger web, connected by shared fragility. Silence may frighten, but it also magnifies awe. It reminds us that to live, to breathe, to speak is already extraordinary. Still, the peril of loneliness cannot be dismissed. A universe without neighbours is a universe without reassurance. If we fail, nothing remains, and a universe with neighbours may be worse. One in which survival depends on hiding, on silence, on fear. In both cases, danger is not external alone, but internal, woven into the psychology of existence itself. From this silence, attention must turn again outward, for the cosmos is not finished with its threats. Beyond loneliness, beyond signals and shadows, lie dangers stranger still. Dangers not from stars or civilizations, but from the very architecture of reality. For if the universe itself is unstable, then perhaps the greatest peril is not annihilation by others, but dissolution from within, the collapse of dimensions, the unravelling of space-time, the quiet betrayal of reality itself. If loneliness is a danger of silence, then the final peril is one that silences everything, the collapse of reality itself. For all the threats we have traced, asteroids, black holes, gamma-ray bursts, cosmic strings, alien hunters, each assumes that the universe continues, that the stage endures even as the actors vanish. But what if the stage itself is unstable? What if existence in its entirety can fall apart? Modern physics whispers of higher dimensions, of brains and multiverses where our cosmos is but one membrane floating in a greater sea. In string theory, dimensions curl invisibly around us, compact and unseen, yet essential. If they were to shift or tear, reality as we know it could unravel. Space might ripple into knots, time might fracture, matter might lose coherence. The danger here is not from collision, but from geometry betraying itself. Some theorists imagine brain collisions, in which universes themselves slam together. The Big Bang may not have been the birth of everything, but the aftershock of such a collision. If so, another could come, rewriting everything in fire. Others propose that black holes may puncture space-time, tearing tunnels to other regions. A single rupture could expand uncontrollably, devouring our cosmos like paper touched by flame. Even stranger are hypotheses of simulation. If reality is not fundamental but constructed, then its collapse may be nothing more than a switch flipped by an intelligence outside our comprehension. The danger, then, is not of physics, but of cancellation. Existence itself could be discontinued, its patterns erased as easily as code deleted. Such speculation is not proven, but it reminds us that danger is not always visible. Sometimes it is conceptual, a crack not in space but in trust. To contemplate the end of reality is to confront the ultimate abyss. Every structure, every law, every memory would vanish. There would be no witness, no aftermath, no echo. It is annihilation not only of matter but of possibility. In comparison, asteroids and supernovae seem almost merciful, for they destroy within a framework that continues. The collapse of reality destroys the framework itself. And yet, once more, peril carries paradox. For if the universe can collapse, it can also be reborn. The death of one reality may be the birth of another. This silence after collapse may be the prelude to a new beginning, a fresh canvas for laws, matter, and life. We may not endure, but creation itself may continue, infinite in its cycles. In danger lies renewal, though never for those who perish within it. Philosophically, the threat of dissolution presses upon meaning itself. How does one live knowing that all could vanish, not by choice or accident, but by inevitability? Perhaps the answer lies not in fear, but in wonder. To exist at all, however briefly, against such odds is miraculous. To breathe, to think, to gaze at stars is to defy silence for a moment. Fragility is not weakness, but brilliance sharpened by its brevity. Thus the catalogue of cosmic dangers closes, 32 in number, each a reminder of the universe's indifference and our own improbability. Stones from the sky, invisible rays, collapsing suns, wandering planets, magnetic monsters, alien silences, shifting laws, all are threads in the same tapestry, woven of fragility and awe. The cosmos does not promise safety. It promises only motion, transformation, and endings. But danger is not the whole story. Each peril has taught. Asteroids gave us the story of dinosaurs, warning and wonder entwined. Supernovae seeded the heavy elements of our bodies. Black holes revealed the limits of physics. Gamma-ray bursts forged the gold in our veins. Even loneliness drives us to search, to listen, to imagine. Every danger is also a revelation, every peril a teacher. And so the final message is not despair, but perspective. Humanity lives in a universe vast, violent, and fragile. Our survival is not guaranteed, but our awareness is extraordinary. We are sparks that can look back at the abyss and name it. We are patterns of matter that can speak of entropy and extinction, yet also of music, love, and meaning. To exist here, now, is to stand in defiance of the silence that waits. Perhaps one day Earth will fall. Perhaps one day the Milky Way will collide, the sun will die, or the constants will dissolve. But in this moment, the sky is alive, the stars still burn, and thought still flows. The dangers of space do not diminish us, they magnify the miracle of being. The journey through peril ends where it began, with awe. 32 dangers, each real, each vast, each capable of erasure. And yet here we are, listening, telling, imagining. Fragility itself becomes strength, for it drives us to seek, to know, to endure. This is the paradox of existence, that in a universe filled with annihilation, life persists long enough to name the annihilations, that in a cosmos destined for silence, voices rise, that amid dangers, wonder remains. Welcome once again to Arcane Skies. If these stories have stirred your imagination, leave your mark, like, subscribe, and share where you're watching the stars from tonight. For in every corner of the earth, under every sky, we are all fragile, all searching, all alive together in a universe both dangerous and divine.